This is a short video on a standard AP style question in which you're asked about your understanding of kinetic molecular theory and which variables are related to which variables, essentially. So the first question they'll ask you is, they'll tell you have a bunch of boxes, and maybe these small boxes are 1/2 the size of the big boxes. They'll have two different gases. I've often seen them use neon and argon because the formula mass of neon is 20 and the formula mass of argon is 40. But they could pick any pair of gases they like, and they're going to ask you a series of questions. So the first question they might ask you, if it's really easy, is to compare them in terms of their kinetic energy, right? Now, since temperature is average kinetic energy and they're all at the same exact temperature, then their average kinetic energy is going to be exactly the same in all the boxes. So the answer is, A, B, C, D, and E are all equal in terms of this variable. The second question they may ask you is about the root mean square velocity. Now, some students will think that kinetic energy and root mean square velocity are the exact same thing, but they're not. And the basis of that is the formula for kinetic energy. So there's a little bit of physics here. Kinetic energy is equal to 1/2 mv squared, which I'm sure you're familiar with from last year in physics. The basic idea being this: if two things have the same amount of kinetic energy, but one has a larger mass, then by definition it has a smaller velocity, and vice versa. So if something has a larger mass, it's moving slower. Nice and simple. So since they all have the same kinetic energy, we can assume that in terms of root mean square velocity, the smaller particles, right, the ones with the smaller mass, have the greater velocity. So we would assume that B and D have a greater velocity than A, C, or E, based upon the formula for kinetic energy. Okay, the third variable would be probably pressure. And this assumes that according to kinetic molecular theory, it really doesn't matter what the molecules are, just how many molecules there are in a given amount of space, if they're all, assuming they're all at the same temperature. Because it's really just a matter of how many impacts there are. It's not like argon molecules hit the wall with more kinetic energy than neon ones. If they're at the same temperature, the argon molecules are moving slower, but they're bigger, so it balances out. So all you basically do with a question like this is kind of set up a fake ratio. They didn't give you the volumes of the boxes, but we can assume, like, let's say these are all 1 liter boxes and these guys are all 2 liter boxes, and just sort of set up a ratio in our head. So we can go, okay, for A and B, there's 4 molecules in our 1 liter box. That's 4. For C and D, there's 8 molecules in a 2 liter box. Okay, which is also equal to 4. And for E, there's 6 molecules in the 2 liter box. And so we can assume that E, okay, this is equal to 3, box E is going to have less pressure than all the other boxes, and these all boxes are going to have the same amount of pressure. Okay, the final variable they can ask you about is density. And in density, you're going to have to take into account the different formula masses. So again, you can sort of arbitrarily make up values. So you can say each molecule represents, a mole of molecules. So in box number A, you can be like, oh, A's got 4 neons, and 4 argons, so it's like 160 over 1. Whereas B has 4 neons, so it's 80 over 1. For C, you've got 320 over 2. For D, you've got 160 over 2. And for E, you've got 6 argons. So 6 argons is going to be 6 times 4, 240 over 2. So you can just sit there and calibrate. This is 160, 80. This is equal to 160 over 1. This is equal to 80 over 1. And this is equal to, did I get that right? 1, 2, 3, 4, 5, 6, 7, 8. For D, there's 8 times 2. Yeah, 160 over 2. Okay, and so finally you've got 120 over 1 over here. So these two containers, B and D, have the same density, all right? And they are the least dense because it's mass over unit of volume, and neon happens to be a smaller molecule. E, right here, is sort of the in-between guy, Okay, and the densest two boxes are A and C with the heavy argon molecules in the given amount of space. I hope this helps. Thank you.